Hi, I'm Alexander Richter of ThinkG Energy. I'm here with Chris Cheng, the Managing Director of Eavor in Germany. Chris, thanks for taking the time to meet with us.
My pleasure. Good to see you again, Alex.
Eavor and its activities, of course, everybody is very excited of what you're doing in Germany, of course, and beyond as a company. You have been now drilling and working on a project in Geretsried in Germany. Mm-hmm. We've recently read that you're moving closer to operation.
Yeah.
Can you give us a little bit of an update on the current status of the project and where it stands?
Yeah, you bet. So, as you know, we've been working on this project for over 2 years. Ran into our fair share of challenges, but of course we're very close to being done, and nobody's probably more excited than myself and the staff here at Eavor. We basically have mechanically finished the drilling and are now in our hot commissioning activities. So what I can share is that we are currently flowing the loop right now on its own with a thermosiphon. So that was very exciting once we were able to turn off our startup pumps and saw the fluid circulating at the commercial rates that we saw. So what's happening next now is we're hot commissioning the power plant. So flowing the isobutane through the closed loop system that's on surface. And eventually we're gonna have the loop talk with the plant so that the plant can start removing heat from the ground so that the Eavor loop can continue flowing. So we're hoping to synchronize the plant with the grid, which means we can connect it with the power grid and start selling some electrons or putting some electrons into the grid in the next couple of weeks, and hoping to be fully online by the end of the year. Fingers crossed.
Well, we're all looking forward to that.
Yeah,
but maybe explain a little bit. We've had some questions. We recently reported on you, and we got this question about the difference between, let's say, the power generation and the heat production. Kind of, how can we envision? Is it the power produced and then the heat after that goes to heating? Or how does it work?
Yeah, so I guess I'll start with physically what's working is we're obviously only ever taking heat out of the ground. So as we're commissioning, the heat comes out of the ground, and before the plant is connected, the loop is just losing heat through the piping and the surface. So a very small amount of heat gets lost and it gets re-injected. So we did that for a couple of weeks just to make sure that the loop could flow on its own. And even just with that, without artificially removing the heat from the Eavor loop, we're able to establish the thermosiphon. So that was very positive. So that means it's circulating on its own. Then we commissioned the power plant, and that's almost like its own separate closed loop. It has the isobutane, it has to flow through the pumps and the evaporators and then the condensers, and we need to test all the surface stuff. And then we have the loop sort of moving vertically and the isobutane moving horizontally at surface, and then they kind of talk to each other through the heat exchangers. And that's sort of the process that we're in right now. So it's a loop commissioning, a plant commissioning, then we make the loop talk to the plant, and then we make the plant talk to the grid.
And so you're producing power to start with.
Yes, exactly.
And of course you also had plans to kind of deliver heat then
That's
to,
right.
let's say, a local off-taker or a grid or whatever.
Exactly.
Is that happening at the same time, or will this be happening at a later stage? And how does that process work from a heat exchange kind of delivery kind of setup?
So that's more of a, I guess more of a, call it more of a contract, a more business arrangement where the town of Geretsried, they want to see that the loop is operating first for a little while, and I don't blame them for that. And so that's why at first we're going to start selling power. Okay. And then once the first couple of loops are in operation, the town will start constructing the heat net, because one there doesn't exist, so it's going to be a complete greenfield construction. Yeah. We have certain timelines for that. They have certain indicated commitments for how much offtake they think they're gonna use from us. Once that's in place, then we'll preferentially sell heat first, because we want to make sure that all their customers get what they need, and then the grid will just take the remainder. So we're chronologically selling power and then heat, but once everything is working together in a combined heat and power situation, then the heat will take priority, and then any leftover will be electricity.
And I guess then during the summertime you could then essentially sell more power than heat. I
Correct.
guess.
Yeah. If they follow the typical bathtub curve that we're used to seeing, of course, people need less heat during the summer. Then more of our heat from the ground will be directed towards the power plant, and then selling electrons to the grid.
Excellent. And of course, I mean, you've described this as a commercial pilot for forever.
Yeah.
What impact do you think that project has, I guess, both for you as a company, of course, but also for, let's say, additional closed loop projects in Germany or heat development, I guess?
I think everybody is, we can always tell people what we think we're going to do. It's always more powerful when we can show them. So with our commercial pilot, or I hesitate to call it a pilot because we've drilled a couple pilots before that, but say our first commercial plant, our first demonstration of full scale drilling the 8,000 meter wells. It's why we spent the extra time and the extra resources to construct the visitor center. Your typical power plant site, industrial site, would not typically have one, but we've got a pretty nice visitor center, big glass windows, lots of displays showing how deep we're going and everything that we've designed. And so we're going out of our way to show people that we can do it. And so the implications are, once people are able to see it running and functioning and running smoothly, that it'll demonstrate to them that we're able to do that, and hopefully generate some interest for whatever their application is, whether it be heat or power or cooling or anything else that they can utilize with our heat.
Oh, excellent. And of course, this has been a technical undertaking. I mean, you're drilling, well, you said up to 8,000 meters. Yes. You have drilled several loops.
Yes.
I guess for people to imagine the technical aspects. I mean, what are, let's say, the key things that you learned in the process of doing, and kind of how has it helped you now to go into the next set of loops, either on site or elsewhere?
Absolutely. I think there's a funny quote I like to say. It's, we didn't do it because it's easy. We did it because we thought it was going to be easy. And I think we were a little bit falling to that thinking of being maybe over-optimistic. But I think if you're in a startup and you have a vision, you almost need that optimism in order to be enthusiastic and be passionate about the product, right? So I mean, some of the learnings that we had are very much just in the operational excellence side of things. So we had a bit of a slow start until we got the drilling optimized and under our feet. But I would say for the last 2 laterals out of the 6 that we drilled them above what was forecasted. So we're very excited to be able to show that we can do that again for the next loops on location. And of course, all those learnings that we have from, hey, as a Canadian company operating in Germany, that was a learning experience in and of itself as well. How to run a business here. The regulatory environment here is also quite different. And so we definitely want to take those learnings, number one, to the next several loops that are as part of our Gerrit's Reed Phase 1, and then take that to our future projects that we're currently doing detailed engineering and feasibility studies for.
So you kind of like describe, let's say, the drilling management or the process being, let's say, one of the first, let's say, practical aspects for you. But maybe kind of like 1 or 2 little details on the technical side. What do you think is sticks out as something that, well, you would do it differently now? Doing
things differently. Maybe I'll name 2 things. Number one, I think operating, Germany does have some oil and gas, but I think coming from Canada, Alberta, where our province makes 4 million barrels a day of oil compared to 30,000 here in Germany, just working in a jurisdiction that maybe doesn't have the services, there's a lot of things that we would do that aren't necessarily technical, but we would be more prepared about how to acquire certain things with our supply chain, things of that nature. Speaking about a technology thing, though, that I'm very proud of is our ability to do magnetic ranging. So, of course, the crux of our technology is our ability to connect those toes 8 kilometers away from the drilling rigs. And I think the scale and the precision of what we're doing there is sometimes understated. So here we have 8-inch holes, or 20-centimeter holes. They're 8,000 meters away, so 800,000 centimeters away. So think 20 centimeters for 800,000 centimeters.
And then trying to meet.
And then meeting them, exactly. I would say that level of precision is similar to SpaceX landing their rockets again, right? Like you're going way up into orbit and then that little guy is landing back on the launch pad. I think a similar scale of precision that doesn't get appreciated. And we actually developed our own magnetic ranging technology that has reduced the amount of time that we need to make those connections. So when we first started drilling, we were using off-the-shelf commercial technology. And then midway through in laterals 3 and 4, we had our technology following behind in what we called a shadow mode, right? So it's just the backup. And then actually what happened was that flipped. By the very last lateral, we got rid of the commercial technology and we were only using our own. So to make that progression from only 6 laterals, very, very proud achievement. And we're developing that further and continuing to improve it. But that's kind of shows some of the technical know-how that we have within our company to also enable our specific product.
So let's say the last few meters in Geretsried, what's next for Eavor, both I guess in Germany? What's the next project? How is Geretsried maybe then continuing, how that plays, and kind of what's next internationally as well with the learnings from Geretsried?
Yeah, so I mean, we want to sort of, number one, celebrate our current success. I think sometimes we're very hard on ourselves because we've just been running this marathon for 2+ years. We're gonna take a look back, figure out how we want to apply what we learned with loop 1 into the next several loops, see if we want to redesign them in some way. So we're planning to start loop 2 next year, after looking at the lookbacks, the engineering reviews, all those things. We've got other projects within Germany that we're doing. Of course, Hanover is the next most developed project. And then we've got a number of detailed engineering studies and feasibility studies. And I think we also want to just invite everybody to come to our fancy visitor center, come take a look at the loop running and see if that makes sense for you. And I think I'm very excited to see what kind of attention we get and grow our pipeline and really be able to show off what we've done to everyone around the world.
Excellent. Well, that's a great update from Eavor and Geretsried. Well, then all the best for the last few
Thanks so much.
Few
really
weeks
appreciate the time and the
we'll-
support, of course.
and
Very
we'll-
appreciative of that.
And we'll report when things are online in Geretsried. Thank you so much.
Exactly. Thank you, Alex.